Okay, good morning, Algebra. Today's Tuesday, May 12th, 2020. I'm going to hold it up so you can set up your notebook. Please, some of these you may be able to do, but don't fast forward and just do them. There's things I'll be discussing in them that will be important for tonight's homework. Okay, so here are the three problems. Pause and get your notebook organized. Okay, you're back. All right, so number one, given a sub n equals 2,000 parentheses 1.035 to the nth power. Okay, so I want you to think of this, we could think of it as the diamond ring problem if you want. The diamond ring problem is what the ring initially cost, and then what is the rate of increase, or the rate, how much is it appreciating by, and then how many years, or what's representing the years for what you plug in for years in order to figure out, let's just say 10 years from now, or so on. Okay, so I want you to look at this and answer A. What is the initial cost? Which amount would be the initial cost? Pause and do that. Okay, you're back. It should be 2,000. All right, now how do you know that's your y-intercept? But this is to the n power. When it's to the n power, you know this is your y-intercept, so that's your initial cost. If this was the n minus 1, you would have to back up to the 0 power. So you have to be careful with that. But it was written to the n, so this is definitely your initial cost. What is the appreciation rate? Okay, so it's appreciating, and it's appreciating from what? So I'm going to break this up. 1 represents 100, and the 0.035 represents your percent that it's going up. So break it up like this, 1 plus 0.035. Then you could see the 100. Instead of writing it as 103.5, you write it as 1 plus 0.035. Okay, so that's your 100. You don't have to worry about that. This you need to turn into a percent. So you work backwards. When you make it into a percent, you go 2 to the right. If you're taking it into a decimal, you go 2 to the left. So we're going 2 to the right, and you get 3.5. So the appreciation rate would be 3.5%. What represents the number of years? So in this formula, where would you plug in? Let's just say you want to figure out what it would be in 10 years. What represents that? Pause and do that. And that would be the n. Okay. Number 2, a city has a population of 2.3 billion people. It is declining by a rate of 2.4% per year. Write an explicit formula to find the population after 6 years from now. Okay, so I know I want you to pause and write it down, but we're going to break down the formula so you recognize what's happening, because if these are multiple choice questions, you need to know what to look for. Okay, so pause and do the formula. All right, you're back. So you would, if a sub n equals 2.3 billion, you have to be careful. Either you write it as 2.3 billion and you move your decimal point, or you could do times 10 to how many times you want to move the decimal. So let's look at 2.3 billion. When they write it like that, that becomes your comma. Okay, and you put your 2 zeros to get the next one. That means 2,300,000,000. So you would have that many, right? That would be 300 million, so it's 2,300,000,000. That would be that number. You don't really want to write that there if you can avoid it. So what you do is you realize you move the decimal 1, 2, 3, 4, 5, 6, 7, 8, 9 times. When you move the decimal 9 times, it is going by powers of 10. So you could write 2.3 times 10 to the 9th, because our decimal system works by powers of 10. All right, so you can write this either way as your y-intercept, but you can't write 2.3 because it's not 2.3, it's 2.3 billion. I'm going to write 2.3 times 10 to the 9th. That represents 2.3 billion. Okay, that's my y-intercept. Now, in here is my rate. All right, so it's declining. So I'm taking 100%. I'm taking away 2.4%. So do that. You do your 100 minus 2.4, and you get 97.6%. get rid of the percent, and you move it twice to the left, and you get 0.976. And then you raise that to your n power because this is your y-intercept. Okay, now I want to show you another way of seeing that. Instead of using 100, you could do 1 minus and put it right into 0.024, like so. 1 minus 0.024. So this whole thing is the same as this because that's 100 as a percent and that's 2.4 as a percent. Because if you move them first, you would get 1 and that would be 0.024. So it would be 1 minus 0.024. You could do it this way or that way. Okay? And then now you're going to plug in for 6 years. So you're doing, actually, I'll write that out. Sorry. A sub 6, because you're plugging in 6 years. So you do 2.3 times 10 to the 9th, 0.976 to the 6th power. And you put that in your calculator. It's going to probably give you the answer in scientific notation. We'll talk about that in a second. So 2.3 times 10 raised to the 9th. Okay, close it. And then parentheses 0.976 raised to the 6th. And you get, and that works, okay. So A sub 6 equals 198804743. 1, 2, 3, 1, 2, 3. Okay, so that is 1,988,000,000 and so on. All right, and that would be your final answer there. Okay. Number 3. Write a recursive formula using function notation. So we're going to do f of that has a first term equal to 4 and a common difference of 6. All right, let's just write that out so we can see what's happening. So the first term is 4. It has to give you that information. So you're starting with 4. Common difference is your slope, don't forget. Common difference, that's your d, right? In this, your slope of 6. So 4 plus 6 is 10, plus 6 is 16, plus 6 is 22, and so on. So that's what your sequence would look like. All right, so now you're going to use function notation to represent that. So we're going to say f of, and you have to decide what you want your before and your after. I'm going to use f of n, and then on the other side then I have to use f of n minus 1 because this is my after and this is my before. And then I'm just going to simply add 6 to it. Okay, so what do? I decide on what my before is. So my before is going to be n minus 1. So that's going to be my before. And this is going to be my after. You could have used f of n as your before and f of n plus 1 as your after. You have to come up with a before and after. In a recursive, you'll see an after and a before on both sides. And then you have to say what f of 1 is. F of 1 is 4. You have to give that information. You have to give that first term. So this would be the completed recursive formula. So you have what you're adding each time and you're telling what to start with. And that's it for today. Okay, you're going to see problems just like these on your homework. Please pay particular attention to what you did on the video.